Hey guys, today in this tutorial what we're going to be doing is we're going to develop a Guardian from Legend of Zelda Breath of the Wild. It's not going to look the same obviously because I don't have the models that they use in Breath of the Wild, but what we're going to be focusing on in particular is the AI. So we'll start with the Guardian, the Decayed Guardian, which is the one in the ground where Link runs past and it has a sniper beam that comes out of its eye and locks onto Link. Does like a ticking countdown sort of thing and then launches a fast as fuck projectile Link and blows his brains out essentially. We'll start with that. Maybe later on we'll do the Guardian Stalker, the one that runs around, and maybe the Skywatcher, which is the one that floats in the sky. But it's not necessarily hard to do, but there is a lot of different things involved, and it is going to take a while. I doubt we're going to get it all done in the one video, but let's just crack into it, and we'll just see how we go. So this project is something that I've been working in for the last couple of tutorials in this series. This tutorial is somewhat unrelated to, well, it's unrelated to everything that we've been doing so far, so don't worry if you haven't been following along with any of those. Just open up a new map and we'll just create a new level. Hit Control S to save. I'm just going to create a new folder in my content browser and I'm just going to call this I'll just call it Guardian folder for all the Guardian stuff, and this is just going to be our Guardian map. Okay, so I'm just going to make the ground a little bit larger. I'm going to reset the position to 0, set that to 10. Okay, now first things first, let's see. What have we got? BT Guardian. Okay, so in our Guardian folder we're going to create a new blueprint class, and this is going to be of type character, and we're just going to call this Guardian BP. So let's just go in and set up this Guardian. So we'll just use 2 static meshes for his body, just to keep him really simple. So let's go static mesh. We can call that base. And then can I duplicate that? Yes, and we'll have another one called head. And we might have another one which we'll call eye as well. And we're going to attach the head to the base and the eye to the head, like that. Now the base is just going to be a cylinder, so you'll want starter content enabled for this tutorial. We'll put that down at the floor like that, maybe scale it out a little bit. I don't know, so it looks something like that. Let's just check that for size in the viewport. And how big's our mannequin? So we want it to be a little bit bigger than that. So I'm just going to grab that white square in the middle, drag him out like that or something, and then we'll grab the head and we'll go cylinder again. If you don't want to know how to make this, you're not interested in this shitty cylinder mock-up of a Guardian, you can just tap the right key on the keyboard to fast forward. This is going to be our Guardian head, so this is going to be the bit that rotates around. So maybe what I'll do is I might make this one a little bit smaller down there, and then this thing can be a little bit thinner. Oops. Maybe a little bit taller or something. Yeah, it's kind of hard to say. I suppose it doesn't really matter at all, does it? Let's just roll with that. That can be the Guardian head. And then the eye, we're just going to grab a material sphere. Oops. Material sphere. And now, see how this is scaled all funny because it's parented to the rest? What you can do is you can just reattach that back to the root. Hit reset on the scale and then reattach it to the head, and now it'll be back to its normal size. So if we look at our x-axis down in the bottom corner of the viewport, we want this to be facing forward on the x, so the eye can just be up here like that. I'm gonna turn off my snapping for a sec and just bring that down like that, make him a little bit smaller. That can be our Guardian's eye. So this is obviously a fucking hideous Guardian, but if you've got your own models you can make your own and do whatever, but you know, it is kind of cool. What's important in these games is the way that they behave. I think that's the scariest thing. It's not necessarily how they look. Their behavior it really makes or breaks the mood of the game. So if I just go Alt and then H, we can get this side view here. So now what we want to do is we just want to match up this capsule component so that it fits with what we've got here. So we just want the bottom of the capsule to be touching the bottom of the Guardian down like that, and then just probably make it as wide as we can get it, just like that. That's fine. He's not going to be walking around on the ground anyway, so it doesn't really matter. And then just go Alt G to go back to here, and that should be all good right now. So this is our ugly draft guardian. Yeah, look, that's a decent size. He could be bigger, but whatever. Okay, so I've got a little list of things, that we need to do today. So I've already explained that. Oh, so we might be using some of the logic that we've used in the previous tutorials, but I'll explain that as we go, and I'll show you what we've done. That's not really a big deal. We've set up the body from the static meshes, so let's set up his AI controller and behavior tree and all of that. How have we gone? 5 minutes in already, Jesus Christ. Okay, so off of begin play, well, the first thing we need to do actually is go to Guardian BP self. We're going to give him my AIC, which is something we set up in the first tutorial, and auto possess AI when he's placed in the world or spawned. Now, in the my AIC, I'll show you what we've set up in the previous video, but if you do want to know how to set this up yourself, just go and watch the first tutorial. I'll put a link in the description as well. So we had this setup AIC event, which sets up the AI controller with all the information that's required from the AI that it's going to be controlling. So that just does, like, it saves the behavior tree, it saves the pawn sensing target. We've built some pawn sensing in here, which I might just comment out now. Pawn sensing and setup. Now the pawn sensing that I've got set up here, we are going to use that for a little bit today, but we're going to build our own pawn sensing for this Guardian later on, because what we're going to be doing for the Guardian is his head is going to be the part that's rotating around to follow Link, not his whole body. And when you've got pawn sensing in here or in an AI controller, like the default pawn sensing, I'm pretty sure that you need to rotate the entire actor to get the pawn sensing to rotate. You can't parent it to one of the individual components, which is fucking annoying. And I could be wrong, like I could be doing this completely wrong and I could have missed a feature, but what we're going to do to get around that problem is we're going to build our own pawn sensing that can be attached to the eye, so when the head rotates, the pawn sensing will rotate with it. But more about that later. So this is something we set up in the first tutorial. Basically all it does is just runs a behavior tree and then just updates some Blackboard variables. So let's just go into our event graph here, and we are going to I'll show you what we're going to do actually. We're going to go to we built a patrolling AI back here, and I'm just going to copy what he said at the start. Okay, so I'm just going to copy that. So all this is doing right now is it's getting the AI controller, which we've set here to my AIC. We're casting to my AIC, so we have access to this event here, which sets up the AI controller, and then we're just sending it the behavior tree that we want it to run, and the pawn sensing target, which is the player pawn. Okay, so the behavior tree down here, we're going to need to create a behavior tree. So if we go back into our Guardian BP, oops, sorry, not the Guardian BP, we want to go to, if I press Control B, I can go to the folder that's in, and then in here we're going to go to Artificial Intelligence, and we're going to create a behavior tree and call that Guardian BT. Okay, now this can just be, for now, just to select a node. So it's going to select a behavior, and the only priority that we're going to put in is a wait. So it's just going to wait when this is running. Now, this will automatically have a Blackboard associated with it, I think. We can just use the AI Blackboard that we've set up in a previous video. That's fine. Okay. So now this guy's running a behavior tree, and inside the behavior tree, the target variable is going to be set to the pawn sensing target, which is the player pawn, and the origin key, this one right here, that's the target, that's going to be set to the player, and the origin key is going to be set to the location of the controlled pawn at begin play, which is the location of our Guardian here at begin play. So that's all that's happening. It's just running the behavior tree and setting these two variables. They're just things that we always want, well, I always want in a behavior tree stored in the Blackboard at begin play. So that's all. And this little function here, if you haven't seen that, by the way, that's just a little thing that we made up in the first tutorial. It's just a function in a function library that we built that allows us to set any kind of Blackboard variable that we want quickly and easily. So that's what it looks like if you're curious. But I show you how to do that in the first video. Now, this guy's pawn sensing should be working just fine. So maybe what we'll do is in our AI controller is I'm just going to put a little print string on the end like this just to check that this pawn sensing is working. So this is going to be saying can see, I think. Nope, that's not going to go there. That's going to go right here. So he'll be saying can see right there, and then on the end right here is we're just going to say cannot see. So all that's going on with this pawn sensing is we've got an event which will tick every 0.5 seconds if it sees the pawn sensing target, which is the player. So every 0.5 seconds we'll be getting a message that says can see, and then we have a delay here, a retriggerable delay. So if this is constantly getting called, then this will constantly being re-triggered and it'll never actually complete. So if he's constantly seeing the target, this is never going to fire, and so the rest of this will never actually happen. But when we stop seeing the pawn, this will have time to finish, and then we'll get this variable here which will say cannot see, this print string here that says cannot see. So if we're in here, he can see us right now, and then if we run around the back like that, he cannot see. And he looks like he has a pretty oh, what's that? A pretty wide, I was going to say a pretty wide sight radius. So what's he got here? So set value as object, where access none trying to read Blackboard. Okay, so this function, he hasn't been able to read the Blackboard. I wonder why that is. We haven't given him a behavior tree. Okay, so we've got to go to Guardian BT. That's why. So now he can see us. Now when we run around there, he can't see us. Can see us. Can't see us. Okay, that's cool. So now that his pawn sensing is working, like I said, we'll make that a lot cooler later on. Let's just go into his behavior tree and let's give him a task that'll update his rotation to face us when he can see us. So his whole body is going to rotate around to look at us. And then later on, we'll just make the top component rotate around. So let's just have a few different things down here. Let's just have I'm just going to put a sequence node there with a weight on it. And then this, actually I might just rename that node. I think I can rename that. Or we've got a node comment. Oh, okay, I can give it a name. This is just going to be called search for player, and we're just going to leave that blank for now. That's not going to be doing anything. And then we're going to have another sequence node here. I'll explain why we're doing this in a second. And this one is going to be called attack player. And the condition for attacking player is going to be a Blackboard based condition, and the Blackboard key that we're going to be using to determine if the condition is met is can see target. Can see target must be set, and if we can see the target, then we're going to abort all of the lower we're going to abort all the lower priority stuff so that this runs, and if this is set to false, we're going to abort ourselves, so that's why it's set to both. So if all of a sudden we can't see the target, we want to abort our attack and then go back to whatever our lower priority things are down there. So selector nodes will select a single branch to run, starting from the highest priority on the left. If that fails, it'll search for one on the right, and it'll continue to the right until one succeeds, and then it'll start again from the root. So for our attacking player sequence, what we're going to have in here is we're just going to have a simple parallel node, and this is going to be, down off this branch here, is going to be all of our like targeting with our particle system and the ticking sound and all of that. But while all of that is going on, is we want to have a task which is updating our rotation to always face the player. So the first thing that we're going to do is we're going to have a new blueprint task in here. Go back into your content browser, F2 to rename, and this is going to be called update. Actually, let's call this your to face target, and then I'm just going to put underscore parallel. I like to call my, I'll explain why I'm doing that parallel in a second. So when this receives its execute AI, what we're going to do is we're going to save a reference to our controlled pawn. Controlled pawn reference. We're going to need to get the target, so let's just click on here and just call this target key, and that'll need to be of type Blackboard key selector. Make that public. How are we going for time? 15 minutes. Okay. We're going to get this as an actor, and then we're going to cache that off as well, and we're going to call this target actor ref. I like to cache these off at the start because it's just easier later on, because now I can just drag that in rather than needing these two nodes. Okay, so that's the first thing, and now what we're going to do is we're going to say set timer by event, and the event down here, we're just going to add custom event, and we're going to call this update your to face target, and we're going to hook that up into the timer up there. The time can just be, I don't know, like 0.1 seconds. It can be looping, and we're going to save a reference to the timer up here. So that's going to be timer reference. And so that's all that's going to happen when we execute it, is we're just going to start the timer, and this is going to be updating the location. We're not going to have a finish execute node off the end because we don't want it to finish. We want it to continue to loop. Now what we want is we want our controlled pawn reference, and we're going to set actor rotation. Now the new rotation is going to be a find to look at rotation. The start is going to be the point of our controlled pawn, so get actor location. And now the end is going to be the target location of the end is going to be the location of our target, which is our target actor ref. And now to find the location to look at that. Now what we could do to make this smooth is we could drag off of get new rotation, and we could just say lerp rotator, tick shortest path to true. The beginning rotation is going to be get active rotation of our controlled, sorry, not location, get rotation of our controlled pawn, and the target rotation is going to be the new look at rotation, and the alpha, we could probably make that a variable actually, so let's just call this alpha, alpha, well, okay, alpha, compile save, that can be public. The rest of these we don't want to make public because they're all set within the blueprint. The only ones that we want public so far are the target key and the alpha, and the default for that can just be 0.5. You want that to be between 0 and 1. 1 will make it really snappy towards B, 0 will make it always stays A, and anywhere in between will interpolate between the two, which is where lerp comes from. It's linearly interpolates. Lerp. Will interpolate. Okay, so now that that's updating his rotation, that should be all good. Now what we want to do is we want to add a receive abort AI down here, and this will happen when this condition is no longer satisfied, when we lose sight of the target. This whole tree will abort, and this parallel thing, actually we can put that task in now. So what was it called? Lerp to face target. So this will receive an abort event when this gets cancelled up here. So what we want to do when this aborts is, I guess all we want to do is just cancel this timer ref. So if we just go timer ref, we can say clear and invalidate timer by handle. So that'll stop the rotation from updating, and then we could just say finish abort, and then that'll abort successfully. So now we can comment this, and we can call this receive execute, and then this can be update rotation timer, and then this one could just be called receive abort. And I'm just pressing C to comment things after I've highlighted it. So that should be all good now. Yeah, cool. Okay. And I called that underscore parallel, by the way, because I name all of my tasks with underscore parallel if when they receive their execute, they don't have a finish execute success on the end. That's just a neat little thing that I do to help me keep my stuff organized, so I know what does what. So this will always be used in parallel, and I expect that it'll continue to run if it's got parallel on the end of that. So now what we need to do is we need to add the target key in, which is target. And now if there's a weight on there, which we might just change to like 10 or something, when he sees the target, he should rotate around to face us. And if he can't see us, he's just going to run this search for player node, which I might actually just disconnect. I just pressed Alt to click, and he's just going to wait if he can't see us. So what I might do is I might just go up into modes and just whack in a cube, which I'm going to turn into a wall so we can run behind it and hide from him. How are we going for time? 20 minutes. Okay, so if I start around here behind him, oh no, I'm in front of him and he's looking to face us. So see that? he's following us around, and it is a bit ugly and snappy at the moment, but we can fix that up, I think. And if I run around behind this wall, it says cannot see in the print string, and he is not following us anymore. And if I run around here, we're still out of his sight. Can I jump on top of him? Nope. So anyway, if I walk in front of him again, now he's looking at us again so he can see us. Cool. Okay, so let's make that a little bit smoother, because that was pretty ugly. So I think what I could do is, this is only firing 10 times a second, so what if I just make that 100 times a second? 0.01. 0.01. We could make that 100 times a second, which might be a little bit overkill actually, so let's go 50 times a second. 50 FPS. And you can use your frame rate as well. That's much smoother, that looks really good. So he's following us wherever we go. But I think he is actually going to rotate upwards now if we jump. See this? His whole body is rotating up, and that's not what a Guardian does. So what we want to do is we want to go back into this parallel thingo. And when we do this lerp thing, we just want to break the value. We can break the rotation value here. I think we might just want to break this one here as well. The roll can always be the same, the pitch can always be the same, and then the yaw can come from the lerp here. Let's see how that works. So now if we jump, he's not tilting up to face us, but he's still yawing around to face us. Cool, okay. That's all good. So now I guess we can get started with the beam itself. That's pretty much all we need. If you wanted to give him a sound when he saw you, by the way, you just put a do once off of this, and you just have it reset whenever this fires down here, which I'm not going to do right now because I can't be bothered. But the reason that I brought that up is because there's a terrifying sound when the Guardian sees you in Breath of the Wild, followed by some absolutely terrifying music, and that would be kind of cool to put in. I've actually built one of these before. I've built a Guardian Stalker in a different game, which I might show you at the end of this. It took a while to make, so I don't know if I'll do a tutorial, but maybe I will. Maybe I will make it. We'll just see how we go. So what's this here? Patrolling AI. We can close that down now. We'll leave the behavior tree open. The AI controller can stay open. And I'm just going to comment this and say begin play for our Guardian BP. Alright, so I guess we can get started with the actual Guardian laser, the Guardian beam. So I have two assets in here that are from the marketplace. One of them was called laser something. P beam underscore beam underscore laser underscore fire. This comes from the Infinity Blade effects, which you probably have used before, but just in case you haven't, I'll show you. Feel free to skip ahead if you have used these and you know exactly what I'm talking about. They're on my projects. Some of them more retarded than others. Pleb Patrol, for example. What have we got here? So it's called Infinity Blade. Oh, fucking hell. Infinity Blade effects. I probably don't need to show you this, actually. Well, look, this is going to take forever to load, so I can't be fucked. But it's called Infinity Blade effects, and it's just a bunch of different particle systems. You can see it just there in the, what do you call that, a thumbnail or whatever. Infinity Blade effects, in effects, FX monsters, FX monster elemental fire. You want to get this thing here. Or you could build your own. It just needs to be a particle beam system, if you know what that is. Where is it? Oh, it's compiling the shaders. Okay. Hopefully it works, because I just migrated it from another project. So we're going to be using that, and there's another one called projectile lob fire, something or other. P underscore projectile lob fire source. This is going to be our thing that we're actually launching. This could be absolutely anything you want. I just chose this one because it has a really nice tail behind it. And if you watch the Guardians in Breath of the Wild, their projectile, it doesn't instantly hit you. It's just a really fast sort of beam that you can see the trail just there like that. It's just a really fast beam that fucking just flies at you from across the sky. And I just thought this one looks kind of cool, so that's what we're going to use. So maybe what we can do is let's set up the beam system first. So while we're turning to face the player, let's have another simple parallel node. And the task off of this can just be called, this will be the actual beam charging. So we'll call this new task. And then if we go into our folder, where our new task was just created, which I have no idea where that is, in Guardian maybe? Yeah. So F2 to rename. I'm just going to call this Guardian Charge and Blast, BTT. Now this one's going to be quite a big task with a lot of different stuff, and like I said, we may or may not get through this today, depending on how well my brain holds up. I can't do long tutorials, man. Like, I can't spend ages in front of the computer without my brain sort of shutting off, so let's just see how we go. So when we receive the execute, the first thing that we're going to do, we'll save a reference to the control pawn. And what we'll do is we will create an emitter, I guess. So we'll create spawn emitter attached, actually. Yeah, that could be good. Let's spawn emitter attached, and we'll attach it to the controlled pawn. So the emitter template is going to be our laser, whatever it is, laser beam fire. Attached to component, we'll attach it to our, I guess we could attach it to our capsule component. Actually, no, we want to attach it to our eye. So to get a reference to the eye, I'll show you a smart way to do this. So what you could do in here is you could grab off of this and you could say cast a guardian and then get the guardian eye and then put that in there. But then this whole task will be useless to any other controlled pawn that wants to use a guardian beam. So you could actually have guardian beams for any different kind of enemy you want if you set this up properly. So I'll show you how to set this up properly. We need to add another. We're going to add a component. We're going to add a let's use a scene component actually. We'll add a scene component and call this Guardian Blast Info component. And what we can do is we can set up all of the things that we need inside of this that the task needs. So then that the task can get its information from this rather than from the actual specific guardian. And then what we can do is we can add this to any different actor, and it's kind of like what do you call it? Like a mediator, or like an intermediate, or an interface between the task and the specific pawn that's using it. So I'll just show you, and maybe it'll make sense as we go. So Guardian Blast Info component. Let's add that to our Guardian. And this was sorry, I probably should have explained. This is a scene component. So when you create a new blueprint class, you've got actor component or scene component. Scene component has a transform. We definitely want the one with the transform. So now, because it's got a transform, we can go into here and see where it is. Let's attach that to the eye and then reset its location, rotation, and all that, so that it's right there. And that's where our origin of the beam is going to be, right from there. So now that we've got that, if we go into our Guardian Blast behavior thingamabob, we can, I think we might have set up a function actually. So get component if valid. Yeah, we set up a little function for that. So if I just open this up, all this is doing is, maybe I'll just build it again. Fuck it. I got a feeling that was a shitty function anyway. So let's say no, it's off of here. So we need to drag controlled pawn ref and say get component by class. And the class that we're going to be getting is called something info component. What do we call it? Guardian Blast Info component. We'll need to have an isValid node off of there. Now, if it's not valid, we're going to print a string, which is going to be saying task needs Guardian. Actually, I don't know a better way. Append task needs but doesn't have component, and then into B. I'm just going to hook that up to there like that. So that's if this tries to get the component but it doesn't exist. And just give me a second, I'm going to turn on my fan because it's starting to get really hot here today, and this is going to get a little bit noisy, but bear with me. God, hopefully that's not too bad. It's facing away from the camera and I can just talk up close to the camera, so hopefully that still sounds alright. God, that's even distracting me. So now, if this is valid, let's promote this to a variable and just call this Guardian Blast component ref. And so now what we can do is that's all just setting up. So now over here, when we say attach to component, what we do is we just get this Guardian component ref and we just attach it to there like that. And now we can use this behavior tree task with any AI that has that component, because it knows that it just needs that component to attach it to. Okay, so spawn emitter attached, keep relative offset. I think we want to have this snap to target, keep world scale, so that it always snap to this component. Yeah, I think that's good. So now let's promote that to a variable as well, and just call this current beam ref. And when's that running? So when we're turning to look at the player, let's add our task in here, which was called Guardian Charge and Blast, and then while that's doing that, let's just have it wait. If you had like a Guardian Stalker or a Skywatcher or whatever, down off of this here is where you'd put its movement. So if you had a Stalker, it'd be running around and chasing your player. If it was a Skywatcher, you'd have it flying around, etc. And all this, while it's flying around or walking, it'll be charging its beam constantly and reshooting. Okay, so now if this receives an abort, so receive abort AI, and I might just put that up on top of here actually. If we receive an abort, we're just going to grab our current beam ref and we're going to check if it's valid. If it is valid, we're just going to destroy it. And we might just put a little print string as well, just so we know that when it's aborting. This is just helpful for debugging. So print string aborted beam. Alright, let's see what happens. I'm just going to change my play to current camera location so I can start behind this dude. So now if I walk in front of him, he should spawn his beam. There, look at that. Oh, now we're getting somewhere. Now you see the length doesn't quite update. Well, it doesn't update at all actually, it's just the default length. But it's definitely facing in the correct direction. But we can make this a lot neater actually. See, it's still a little bit jerky. We can make that neater. Oh, this is exciting, we're getting somewhere. Oh, and let's just check that it aborts. So if I run in front of him here, he's spawned his beam, and if I run around the back, he's aborted it and he's destroyed his beam. Beautiful. Alright, how have we gone for time now? 32 minutes. I don't think we're going to get through all this today. I'm starting to get a little bit tired, but that's okay. Okay, so now down here, now we need to use some nodes to set the beam end location. So I can't recall what this is off the top of my head, but let me just see if I can find it. Set beam endpoint, that'd be it. Now I think it'd be emitter index 0, but I'm not entirely sure, so let's just check that. So type in laser beam. I'm not too good with particle systems, I'll be real. What's this? I'm gonna guess that that's index 0 because it's on the far left. So yeah, I guess that's what we want. Okay. So now, what's this? This is that info component. We can close that for now. Actually, what we want to do is we want to set a function that does this. So to do that, let's say set timer by event. Do we want that to be event or do we want that to be... Yeah, let's just have an event. Okay, and let's just have a custom event down here. And this is going to be called update beam location. You can use a function instead of an event. So let's use the world delta seconds here. So get world delta seconds, so that'll just use the time between each frame. That should be looping, and then promote that to a variable, and that variable is going to be called update beam end position timer ref. Clumsy name, but you know, it gets the job done. And then whenever we abort, let's just add a reroute node here off of that, and then hook that up into there as well. And then add another reroute node, and then I'm just going to collapse this here to what should that be? Should that be, let's just collapse it to a node, and this is just going to be destroy beam. Now, so that's going to check if the beam is valid, and if the beam is valid, or it's going to destroy it. If it's not valid, it's just going to continue, and then the next thing it's going to do is it's going to clear and invalidate the timer. Okay, you didn't need to collapse that. I don't know why I felt like doing that. I just feel like it's neater. And I like to keep things commented actually, so I might do that. I'm just going to call this, well, this one here, receive, execute, receive abort. Now this here is just going to be called setup. That here can be create beam. And then this one here can be called, actually this can all be just create beam, because that's part of creating the beam. And then down here we'll call this update beam end position later when we finished it. Okay. So now what we're going to be doing every frame, because we've set that to world delta seconds, is we're going to be setting the beam endpoint to the location of our target. So what we need to do is we need to add a new variable in here, which is going to be called target key. And this is Blackboard key selector type. Compile, save, make that public, drag that in, get as actor. And you know what? Let's actually just cut that and then put this in the setup up here. And you know what we might even do is you might just collapse this to another thing, and we're just going to call this setup variables, just to keep it nice and neat and all of that. So inside of that, it's doing its whole thing where it's setting up the components there. And now what we're going to do over here is we're going to get our target key, and then we're going to promote that to a variable, and that's just going to be target ref. We're going to promote that to a variable just there. Okay, so that's all good. Now that needs to be public because we're going to be setting that in here. Target key is going to be target, and target is set in the AI controller right here, I think. Yeah, so the key name target is set to object value pawn sensing target, which comes from the event, which is called from inside of the begin play, there, player pawn. Okay, so now if we go into here, the location that we're going to be setting as the endpoint of the beam is going to be get actor location of our target, and that'll be called every frame. You know, it could really be that simple. That might be all there is to it. No, okay, so it's not updating the endpoint. Let's see why that would be the case. So it's definitely creating the beam. That's looping. World delta seconds is the time. Let's just add a print string here, just to check that it's actually updating the position, because maybe that event isn't firing for some reason. So let's come in. Okay, it's definitely updating. So the other thing that could be going wrong is maybe the emitter index is the wrong index. So let's go back into here. I'm pretty sure I checked this, but then again, I don't really know how to read these friggin' particle emitter thingos. So what's this one say? Source glow. What if I just type in 1 and just see what happens? I'll just YOLO it. I should probably learn a little bit more about particle systems so I don't waste so much of your time with these tutorials. Oh, beam distance. What do we got here? Oh, distance. No, I think we want that to be target instead of distance. Yes, okay, so if you go to beam data and then where it says beam method, instead of have that set to distance, because I think that just means it has a fixed distance, if you go to target and then save it, I've got a feeling that'll let you use this node where it might not let you use it otherwise. This could be completely wrong. If this works, this is going to be a miracle. Okay. I wonder what's going on there. Maybe the start point is the other end. So maybe what we want to do is go into here, and instead of setting the end point, let's try set the start point. Source point. Okay, so set beam source point is definitely the one that we want. Well, it's not definitely, but let's see. That's the one I was looking for anyway. So new source point. That's weird that it's backwards like that. Anyway, let's see what happens now. Nope, that's still being retarded. Okay. I wonder why. Feel free to skip ahead, guys, while I figure this out. Let me just check what my target reference is, because maybe the target reference isn't valid. No, it's definitely the third person character. Okay. Alright, I'm just going to pause this and I'll figure it out. Okay, I think I figured it out. I'm not 100% sure, but I think I've got it. Let's see. So in our Guardian, the P-beam laser fire thingo, what we want to do is we want to add in a... Go to beam and add in target. You need a target component in there like that. And now the target method needs to be user set. And now... Well, actually, is there a beam source? Yeah, there's a beam source as well. So you know how I was playing around with source and target before? You actually need to add in source or target inside of this. And then that'll help you. It'll allow you to set it from the blueprint. So now that we've got target in there and it's user set, I don't think we need to give it a name. I think that'll do just as it is. If we go to our Guardian Blast thing, we can close endpoint. We can get rid of source point as well, and we should just be able to say set target. Yeah, set beam target point, and that should do the trick. So new target point can go in there. And actually what we might do is let's just add a lerp in there as well, and let's just test that this works first actually. So maybe let's just get rid of that. Okay, compile, save. I think that's everything I needed to do. Let's jump in and see. Boom, perfect. Look at that. That's snapped right to our player. Now when you move really quick, it is a bit glitchy, like it's not quite following him perfectly. What just happened? Oh, maybe his behavior's done something retarded. Maybe this finished, or the weight finished or something, I'm not sure. Anyway, that seems to be working, so let's just roll with that as it is for now. We could make it a little bit smoother, but you know, let's just leave it like that. That's actually pretty cool. There's no need to play around with it too much. So this is update beam location, like that. Now the only thing that we need to do is we need to add in a countdown, and we need to add in a projectile launching thing. So the way that we add in the countdown, so when you're being chased by a guardian in Breath of the Wild, it sort of has this ticking sound, and the tick gets faster and faster and faster as it gets closer to detonating. So what we could do is we could use the time that's elapsed here to run a tick event, a ticking sound thing. So the way that we do that is we could have a custom event down here, which could be called begin ticking. And then have another custom event which could be called tick, like that, and off of this bit here we could say begin ticking, and this can just set up a bunch of different ticking parameters for our thing. So now whenever we tick, let's just say spawn sound 2D, might as well be a 2D sound, because if you're targeting the player you want to be able to hear the sound. I think I actually do have a ticking sound which I can give you. I'll put a link to that in the description. It's called single tick. So that'll do the ticking sound. Then what we'll do is we'll have a delay, and the delay can be time between ticks, and then we can just tick again, I guess, or maybe we can have a branch. And maybe the branch can be... So perhaps after a certain amount of time, we can fire another event. So after this has started, we'll have it elapse a certain amount of time, and then we'll fire an event which will clear this function here. And when this function is cleared, this will stop updating, and we can also use the time lapse for this function. So when this function is cleared, we could have a branch here which will stop this from continuing to tick. So let's use our update beam position timer ref, and we can just say is valid. So if the beam does still exist, then we can tick again. If it doesn't still exist, then just go to nothing and it won't loop back to the tick. So I don't think we even need that begin ticking there. Oh, let's just leave it there for now, and let's just have that called tick like that, because maybe we'll add some setup into that later. So when we begin ticking, it'll just go to tick. Let's just highlight all of this and call this ticking. Tick 9ing, T9 king. Now this here we'll highlight and just call this update beam location position. I said location, but I typed position. And then over here we can have another custom event which can be called launch projectile. Or maybe it can be called end countdown. That's more specific. Now what we're doing over here is after we begin ticking, let's say set timer by event, and actually let's put this up here. So this is the timer that we're going to be using, so that's going to be attached to that like that. The time that we're going to be counting down, we can have that promoted to a variable which can be countdown time, and we don't want that to be looping. We just want this to fire once after whatever time this is set to. So let's say it takes 5 seconds for the beam to fully charge. Now that's the countdown time. What we want to do here for the time between ticks is we'll want to set the time between ticks as a linear interpolation from how much time has elapsed and how much time we started with. I don't know if that makes any sense. It doesn't even really make that much sense to me at the moment. I can't really quite put it into words, but let me just see if I can knock it up. Sometimes I can't quite articulate what I'm doing, but I can just kind of go into like autopilot and do it, and then I can usually explain what I've done afterwards. So let me just see if I can do this. So that's going to be setting that amount of time. It's going to check if it can tick again, and if it can tick again, let's set the time between ticks here to a linear interpolation. So we'll type in lerp between I don't know, let's just grab our countdown time and divide that by let's say, I don't know, like 5. So it can start as a fifth of the entire countdown time, and it'll end as I don't know, the time between ticks at the end could be like 10 times a second or something, and the alpha can just be, now the alpha actually will be the elapsed time of this. So we'll grab this here. Actually, you know what, we don't need the countdown times are irrelevant. What we could just, actually no, it's not quite irrelevant. Let's just leave that as it is for now. That'll work fine. But we might actually make that a bit bigger. Let's make that like 10 or something. So say if your countdown time is 10 seconds, your ticks will start 1 second apart and they'll go down to 10 times per second. Now the alpha, we want that to be the elapsed time, so we'll say get elapsed time from here. And we also want the total countdown time. And I think what we want to do is we want to normalize this. I might just pause this for a second and figure this out, because it might take me a while, so just give me a sec. No, look, I think I've got it. So what we want to do is we want to grab our is that actually recording? Yeah, it's recording. So we want to grab our countdown time and we want to say minus float, and we're going to be subtracting off the time that's elapsed. And then what we want to do is we want to go div float from that, and then we want to divide that by the total countdown time. So what this is doing, and then we plug that into the alpha. So what this is doing, let's say the countdown has just started. Our countdown time will be, I don't know, 10 seconds or whatever, and this will be 0. So then this output here will just be completely the countdown time. So the countdown time divided by the countdown time is going to be 1. So the alpha is 1, which means it'll be B, which will mean it's going to be the slowest tick time. So we want that in there like that, and then 0.1 in A like that. So when this is not elapsed any time, the countdown time divided by the countdown time will be 1. Alpha of 1 gives a result of B. Now, if the time of this is equal to the countdown time, so in other words, it's fully elapsed basically, then this will be 0. 0 divided by the countdown time is 0, so the alpha will be 0, which will go to A, which is 0.1. Hopefully that makes sense. This is called normalizing or something, I think, like that, where you yeah, I don't know. I'm not even going to try and explain it. I just remember we did it in school once, and there was a little formula with an n minus 1 over n or something rather, or n minus x over n minus max, or some shit. It doesn't really matter. The point is that we figured it out. Well, I think I figured it out. I shouldn't get cocky just yet. So that's going to update the time between ticks if it's allowed to update the ticks, and then it's going to tick again. And it's going to start ticking whenever this it begins updating the beam position. And then after it's elapsed the countdown time, maybe this is the time that we wanted to use. No, that's okay. This will work just fine. So when it's elapsed that time, let's just say spawn sound 2D. And we'll launch the projectile in a second when we've actually made the projectile, but let's just have it spawn an explosion. And then what we want to do is we want to destroy the beam, stop all of the functions. So you know what we could do actually is when we've got this destroy beam up here, we could promote that to a macro. Oops, and let's just call that destroy beam and stop ticking. So when we abort, we want to destroy the beam and stop the ticking, obviously. So what's this here? This here is destroying the beam. This here is clearing the beam updating timer. We'll also want to clear the ticking timer. So what did we call that? Let me just compile and save that for a sec. The ticking timer. Oh, so the ticking timer is actually, well, that's not actually a timer. That only just continues to run when. That only continues to run when we've got the update beam end position timer ref, which is being cleared back up here. Update beam position timer ref. So when that's cleared, the ticking will automatically stop. My brain's getting a little bit tired, but we're doing okay. Is that all we need to delete? I think that's all we need to delete. So when we spawn the sound, we can just say destroy beam and stop ticking like that, and that beam will be done. And then what we'll do is we'll spawn the projectile after that, and then we can mark this as a success. So you know what, actually, we could just have a delay. So it'll spawn the sound. Let's spawn an emitter as well, why not? Because there is a big fancy emitter in Breath of the Wild when the Guardians spawn their projectiles. So let's just spawn an explosion. The location will be... We saved the component reference, Guardian blast component thing. So let's say get world location. World transform will do. Let's just roll with that, split that, add that into there. The scale of that, let's just make that a bit bigger so we can see it. Okay, so now that spawns an explosion, makes an explosion sound, it'll destroy the beam, and then it'll wait, I don't know, 3 seconds, and then we'll say finish execute. Mark that as a success, and then when that's succeeded, the behavior tree should start from the root again, and it'll all start again. So now, let me just highlight all of this and just call this, actually no. Let's call this finish countdown and launch projectile. And this can be just called countdown to launch. And you know what we probably want to do is we want to promote that to a variable and just call this countdown to launch timer. I'm just going to drag that across a little bit, and inside of this destroy beam thing, right, we're just going to can I attach both of those? No, I can't. We're going to clear and invalidate that as well, just to be safe, in case some weird shit happens where this, I don't know, we just want to clear it. Maybe that's just me being superstitious. Probably is. So now let's see what happens. So if we play now, he should do the ticking sound, and when it finishes the 5-second countdown, I think it's just what we set it to. We set it to 5-second countdown. The ticking should get faster and faster as it gets closer to the end, and then once the 5 seconds finishes, it'll spawn an explosion, etc, etc. The beam will be destroyed, he'll wait, and then it should restart. Fingers crossed. I'm skeptical. Okay, it's ticking. Eh, I mean, it kind of worked. The ticking's not getting faster, though. The projectile is definitely working. And he's starting again, so that's good. That's really good. And if we hide, it aborts. It's a bit of a sketchy abort, but hey, it was an abort. And it looks like there are some other problems there as well, but we can address those in a sec. So the ticking wasn't getting faster, which makes me think that this here isn't working. So the countdown is 5, and then the elapsed time by handle of the updating beam position. Maybe we should just get this to print. Let's just print these values that are coming out of this. Let's see what happens. Well, actually, no, let's print the values that are coming out of this. That'd be more valuable. Let's print the alpha. So it's basically always 1. Oh, it's getting a little bit smaller, but it's pretty much always 1. I wonder why that would be the case. So if it's always 1... Oh, yeah, no, duh, because this is fucking looping, like, instantly. So the time that's elapsed from this is always going to be tiny. So what we need to use... we can keep that there, that's fine. But for this one here, the time elapsed, we need to use the countdown to launch timer. We want to get the time that's elapsed from this here. Let's give that a try. Check that out. Yeah, that's cool. I mean, it ticked twice at the start, which is a bit awkward, but whatever. Actually, you know what? I know how to make it not tick twice at the start, is we just set this time between ticks, where we've got begin ticking here. Oops. We set the time between ticks to whatever we have as our first time here, which is that. So you know what we could do actually? We could promote this to a function and just call this get starting tick time and tick pure. And then if we open that up, yeah, that's fine, just like that. Whenever you copy and code like that, you usually want to use it if you want to put it into a function so that you don't, if you change one, you don't have to go through and change all the others, because we might adjust that later. So that's get starting ticking time. And if we, yeah, that should be good. That should be good. Okay, that works. Yep, didn't tick twice at the start. Okay, cool. Now let's make this a little bit faster. 0.0. What did I have it before? 0.1. Let's go 0.05. Let's see how that sounds. I mean, this is just fine tuning and retarded. This doesn't really matter. Yeah, that works way better. I like that. Cool, now we can get rid of that. We don't need the print string anymore. The ticking's working. Let's go ahead and just create the projectile. There are some other stuff that we'll need to do, like we'll need to tidy up his behavior at the end, because it looks like when this aborts, it can't run again for some reason. So let's just figure out what's going on with that. Actually, you know why that could have been? Let me just go into here. When it receives its abort, we never actually ticked finish abort. It could really be as simple as that. Because I noticed before, when he was chasing me, targeting me, and I ran around the side, he aborted, but then when I walked back in front, he wouldn't start again, and now he's starting again. Fantastic. So as you can see though, his beam does go through the wall while he's aborting. That doesn't really matter for now. I mean, we can fix that. I just don't know if it's worth the effort at the moment. The way that we do that is when we're setting the beam location here, is instead of just getting our target location, is we need to do a line trace from us to the target and then find wherever that hits and then set the beam to that location. Actually, you know, we could do that later. Let's I'm just going to add in a little thing down here that says set beam endpoint using line trace, just so I don't forget about that, because that'd be a good one to show how to do. Now, what do I need to do now? 11 minutes. I think we're probably about an hour into this video so far. It's been quite a long one, but we've covered a lot of stuff actually. Like, this is a fucking complex task. Now, I've bloody completely forgotten what we were going to be doing. Oh, the projectile. Let's do the projectile. So, new blueprint class, type actor, Guardian projectile. There are a million different ways to do projectiles, by the way, and this is just one of them, and you might have your own projectiles for your own system, but let me just show you how to make a really basic one. So, I don't even need a static mesh, actually. Yeah, let's put a static mesh. Actually, no, let's just use a sphere collision. Use a sphere collision, because the particle system that we're going to be using has got a pretty cool looking thing on it. So this can be whatever size, that doesn't really matter, but we want that to be block all dynamic. I'm just going to pause and go to the toilet really quick, BRB. So once you've got your sphere set to block all, that's just going to be the thing that's going to determine the collision. We can add a projectile movement component. Let's turn the gravity off. So if we go to search gravity, set that to 0. We'll want to add a particle system. Now the particle system was that thing I showed you earlier, which was called projectile lob source fire or whatever it was. So this is a really cool one with a really cool trail, so we're just going to roll with that, and that collision actually looks like it's about perfect for it. So whenever this projectile thing, if we have our projectile selected and then we right click and say bounce, add on projectile bounce, so whenever that hits anything we're just going to have it explode. So we could have another function down here, custom event, and we'll just call that detonate, or deto-anti, do once. Could be just spawn emitter or spawn explosion or whatever. So what have we got? I got a blue explosion, that'll work. You can just use the default explosion. We can say get world's location of the sphere, which we're going to rename to block all, not black all, block all. This is just for aesthetics purely, so you don't have to do any of this if you don't want. Spawn sound at location. The location of the sound will be the same as that. The sound will just be an explosion sound. We're going to make that a really low pitch so that it sounds really fucking scary, and it can have a volume of 2. The attenuation, we set that up in a previous tutorial. That's really easy to do. You literally just right click in here and you go to sound and you type in, you go to sound attenuation, and then once you're in sound attenuation, make it linear, sphere shape, and then you set the inner radius where you want it to be max volume and the outer radius where you want it to be silent, there and beyond. And then that's easy, and then you just plug that into there. So now I can delete that because we don't want that. Okay, so now, where was I? We can destroy this. Destroy actor self. So whenever it bounces, it'll detonate and then it'll destroy itself. So we say deto-ant. Oh, and you need to say in here, should bounce needs to be set to true, otherwise it's not going to bounce. Okay, so that is all good, I think. What we need to do in our Guardian charge and blast BP is where we launch our projectile is just here. We can get rid of that delay now. When we destroy our beam and etc, we just want to say spawn actor from class, and now this will be, you know what we could do actually is we could promote that to a variable and call this projectile class, and then the transform that we're going to be spawning at, this might be a little bit tricky because if we spawn it just at the point of our guardian bit, if we spawn it just at this guardian point like that, that is gonna collide with the eyeball and it's gonna destroy itself. So what we could do is we could just drag this out like that and then have it spawn out there. Or I guess what we could do is we could also just leave that like that and then maybe get the forward vector of this. Let's give that a try. We'll get the forward vector of this and then move the spawn point out a little bit. So what we could do here is we might create a new function which is called get projectile spawn point. This might be a little bit of unnecessary maths, but you know, it could be pretty cool to do. So let's just drag that in. We'll make that a pure function. and we're going to get a Guardian Blast component ref. We're going to get the world transform. We're going to split that. We are going to add a vector to its location, and the vector that we're going to be adding is going to be a unit vector multiplied by a float. So this is going to be, no, it's not going to be a unit direction vector, it's just going to be the forward vector. Sorry, get the Guardian Blast component ref and say get forward vector. That has a length of 1, and then we can multiply that by, say, 100. So 100 units forward from the Guardian, or maybe, yeah, 100 units. Oh, let's go 50. 50 is probably enough. I think our projectile was, it was only like 30 across, right? 32 across. So if we take our spawn point, where's our Guardian? If we take our spawn point and then put this out 50 units, that's plenty of room, right, for the thing to spawn. Should be enough. So let me just compile and save everything. That's going to have an error for now, that's fine. So let's just put that 50 units in front of the transform of the Guardian Blast thing. And then let's have a return node. This needs to be plugged straight into that. This is a pure function, that's all good. We're going to have a make transform. The location is going to be that. The scale and the rotation is just going to be the same as the world transform of the Guardian Blast component, and then that goes into the return value just like that. We close that down, and then that gets plugged into there like that. So we could probably name this a little bit more specific. Get projectile spawn point from scene transform. Let's just call it like that. I mean, it doesn't really matter. But anyway, so now what we want to do is we want to say get component by class. Component, not components, and this is going to be the projectile movement component. And now we're going to set velocity, and the velocity that we're going to set it to, you know what, this could all probably be a function in itself, so let's just call this spawn projectile at target, just because that's going to get quite big. So that's actually spawning it. Now this is setting its velocity over here. Am I recording? Yes, I am. Sometimes I forget what I'm doing. Like now, because I've completely forgotten what I was doing. So what I just did then is I've made that public. So now if we go into our behavior tree, we now have the option to set that projectile class to whatever we want. But let's just give it a default value. We're here. Let's give it a default value of our Guardian projectile. But we can spawn any projectile now, so long as it's set up with a projectile movement component here, because that's how we're setting its velocity. So the velocity that we're going to give it is a unit vector times a float. The unit vector is going to be a unit direction vector from somewhere to somewhere. The somewhere it's going to be coming from is going to be this, actually. Let's use this spawn point again. Get spawn point from scene transform. That's where the unit direction is coming from, and where it's going to is going to be our target ref actor location, or actor transform, that's fine. Just split that and then plug that into there like that. Now the velocity, we can promote that to a variable and just call that projectile velocity and make that public. That should be everything for spawning the projectile, unless you want like a sound and things like that, but I've got a feeling we did sounds already. Yeah, we did sounds just up there, so that's just the feedback. So we could probably even collapse that to a function and call that projectile launching feedback, spelt like an absolute spastic, but that is fine. Okay, and now that's spawning the projectile and setting its velocity towards the player, which is all good. And then when that's done, this can finish the execute. And then once that finishes the execute, this will all start again, I think. Once that finishes the execute down here, oh, that just got really big for, oh, I guess because the projectile class just has a really long name. I guess you can hide the details there like that. That's a lot simpler. And you can rename this, by the way, so this could just be called Guardian Blast. Okay, so what our behavior is doing is we've got a selector, so we're selecting the top priority behavior. The top priority behavior is if we can see the target, we're going to attack. If we can't see the target, we're just going to wait. So if we can see the target, we're going to turn to look at the target, and while we're constantly looking at the target, we're also going to be charging a Guardian Blast. And while we're charging a Guardian Blast, we're just going to wait. Now, when the charging the Guardian Blast fails, this all fails and aborts, and then we just go back to waiting. If this succeeds, it launches a projectile and then instantly starts again. Maybe we want a little bit of delay before it instantly starts, so we could have a sequence here. And the first thing that it'll do is wait for this to succeed, and then when it has succeeded, it'll just wait for, I don't know, 3 seconds. It'll wait for 3 seconds before starting again. If this fails though, then this just gets skipped, and that doesn't matter. Okay, so now let's test that the projectile launching actually works. Before we do that, we need to go into our charge Guardian thingo and set a default for the velocity. So let's just try something nice and slow like 2000, so that we don't get blasted and absolutely destroyed instantly. Tick, 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 tick. Ooh, nice one. It was quite small though, wasn't it? That's fine. That looks really good. Except it went straight through us and it didn't bounce. I guess that's the problem with the projectile though. That's not with the Guardian logic. Because this, I have no fucking idea what I'm doing here right now. That's set to block all, so that should be blocking. Unless that needs to be set to like simulate physics or something as well. Or maybe it needs to be made the root. I don't know. Let's just try and make that the root and let's see if it actually works now. But this is working like a dream. Look, he follows you around. The beam's a little bit sketchy, but... Okay, now it's just not doing anything. Now it's bouncing around doing all kinds of retarded shit. Okay, so we don't want that to be set to simulate physics. Maybe a better thing to do instead of on projectile bounce is perhaps we could click on our block all and then simulation generates hit events, and then if we right click we could say add on component hit, and then when it hits something we could detonate. I'm pretty sure this will work. And what we could do here is you could have, there's a bunch of different hit parameters that you could use here to determine what surfaces it breaks on and what will happen on those surfaces and etc. Like for example, you've got like an impact normal. I think that's one. Yeah. So if you take like the magnitude of that, you can determine which impacts are strong enough to actually warrant a detonation. Let's make this beam smoother in a second as well, because it's a little bit jumpy at the moment. Is that going to explode? Oh, it did! Check that out. Alright, let's see if it explodes in our character. Cool! That worked. And what you could do in your projectile as well, when you build your Guardian projectile, is if... So the other actor is the actor that it's hit. You could just do... sorry. Oh, you could just do a cast to character actually. Let's do a cast to character. So other actor, we could say cast to character. And if it is a character, then we're just going to say launch character. And we can launch them away. The unit direction vector will be... The unit direction vector will be from the world location of our block all. So get world location. To the hit actor, which we might want to... I guess we could just plug this down here. Get actor location, and then we can just multiply that by, I don't know, like 600 or something. And you know what we might do actually? Is let's just split this. Actually no, let's just leave it like that, that's fine. I was just going to say maybe we should like angle it up a little bit and just see what happens. Actually yeah, let's add another vector in here, just so that... Let's just add a 0.5 on the Z. So this will have a length of 1, add a 0.5 on the Z, so it's just more likely to be angled up. Just so you get launched upwards. This is just going to launch the player away from the projectile when it hits us. Yeah, just like that. I mean, that's completely unnecessary. You don't need to do that, but I just thought that was kind of cool to add in. Oh, missed me. Okay, now... Okay, what's this? Block all... Okay, so this is invalid now. That's fine. So we need to launch the character before we detonate. That's easy. So all of this here I'm just going to highlight and just collapse to a function, which is just going to be called launch character. What you would do is, instead of just setting this up as a function inside of this blueprint only, it'd be much smarter to set this up in a function library, so you can just call this launch character node whenever you want, and you'd have the inputs obviously to match, to be universal, if that makes any sense. I'm kind of just like rambling at the moment, but this would just be character ref. I'm just not even going to set this up, I can't be bothered. But that's how you launch a character. You launch the character before you detonated, and then your player would be launched away. What's this problem down here? Target, I can delete this now. So that's just how you have your character be shot up into the air. Okay, so now real Guardians have a lot faster projectile than that, so it'd probably be like, I don't know, 10,000. Because they're pretty, like, they're basically impossible to dodge in the game unless you do like a really well timed jump, or unless you're gliding through the air. So let's just see how this looks. Yeah, something like that. That's good. But then again, that's up to you to play around with and, you know, figure out and tweak for yourself. Honestly, I think that's just about everything that we need to do today. I mean, there are a couple of things that you could do to tidy this up and make it a lot cooler. Like, for example, is when your Guardian is just waiting, we could have it, so when this condition is false, instead of just wait like that, is you could have something going on in here where he updates his rotation to look around and look at the player. So the way that, should we do that? To look for the player, sorry, so like he's kind of like turning around in circles and just trying to spot the player. I mean, we could do that. Let me just talk through the rest of the stuff that we could potentially do first, and then maybe I'll do that. I mean, obviously you can make him look a lot cooler. Like, you could give him an eye that is blue, and then when he sees the player, here, you could have this little sequence file. Like, you could have an event here or a task here, which signals back to the Guardian BP that is... How do I want to say this? Maybe what we could do actually is we could invent a new task in here that would change the material of a selected component from a color to a new color. So the selected component that we'd put into that task would be his eye, and then we could have a we could even have a parallel node here actually that says, while this task is running, have the material set this color, and then when it's aborted you could change it back to normal. I don't know if that makes any sense. I could probably do that. Maybe I'll do that in a separate video because I kind of want to wrap this up right now. So I might just add a set beam endpoint using line trace, so beam doesn't flip through walls. And the other thing that we're going to do is say create a parallel node, parallel task that changes eye material while attacking player. So we'll set that up. We could also set up a rotating, I guess it's like patrolling when you're searching for the player, or rotating searching task when cannot see player. So those are all things that we could do later. We've done that. The pawn sensing I kind of explained. Have it rotating the body for now. Yeah, the other thing that we'll do is we'll have it just rotating the head, and we'll build a custom pawn sensing. The Guardian beam, we've set that up. That's all done. So we could do all this in another tutorial. I'm going to show you my Guardian Stalker after this, the one that I've built for another game, and then we could develop a Skywatcher in another video. Okay, that's it. I'm just going to leave this on here, guys. So hopefully that was helpful. We've got a functional Guardian right now. Like, it's pretty good. I mean, he's ugly, obviously, and you could change the particle system and the sounds, and you could change the projectile to look cooler and everything like that. But so one thing that we could do is, his beam is like kind of clippy right now, is we could just make it we could add in a lerp to, where is it, set this beam target point right here. Is this could just be a lerp like that. The target location, is going to be the location of the player, but what we could do here is we could get the current beam ref and say get target point, and then out target point just goes into A, and then the alpha could be, I don't know, like 0.8 or something like that. So now what it's going to do is it's going to linearly interpolate a location between where it currently is and where the target is, so that it's not just snapping each time that updates. I mean, that still looks pretty jerky to me, to be honest. But look, it's not too bad. Depends how fast you're moving. Like, if you're just moving this fast, that looks pretty good to me. Anyway, that's it for this one, guys. I hope you enjoyed this. I fucking love these Guardians. I love Breath of the Wild and everything in Breath of the Wild, to be honest. So if there's anything else from that game that you want me to make, I am more than happy to give that a shot. I've got a video on all the runes, actually. It's not a tutorial, but I've just done a demonstration where I show you them all. And I've got a video, I think I've got a link in that video, actually, that has it's a download link for all the runes. Like, you can download the project and go through it if you want and see how I made it all. I couldn't be bothered making the tutorials for them all because there's just so much content. But if there's anything else that you want me to make, let me know. If there's any questions about this, let me know. And I'll see you soon with another tutorial where I'll go through these other things and tidy up this Guardian a little bit. So I'll see you in that one. Peace out, guys. You know what? I changed my mind. I'm just going to quickly do these last few things right now. So let's set the beam point to the using a line trace. I figured there's not that much, so I might as well just quickly smash through it right now. So where we've got this update beam location here, and we're setting the point, the new target point here, this bit here, the ideal point, we're just going to do a line trace to see if we can actually see the target. So let's put all this into a function right now. Collapse to function and call this set beam endpoint using line trace. I figured I might as well do this now because otherwise I'm probably going to forget how this whole thing works and it'll just be too much effort for me to go through what we've done so far and figure out what needed to be done, so I might as well just do it while it's fresh. So the first thing that we do here is we're just going to have a line trace. This is going to be a fucking long video. Line trace my channel. The start point of the line trace is going to be our Guardian Blast component. So let's say get world's location. A line trace is just a line that gets shot through the air that checks for different collisions and things like that, just to see if there's anything blocking the line of sight from the line of sight of the trace. The end point is going to be the target ref get location, like that. So there's going to be a line trace from the Guardian Blast point to the target location. Actors to ignore, we'll need to make an array for that, and we're going to chug in the controlled pawn reference. We want to ignore that. Let's just add a one frame debug type. Actually, you know what we could do? This is something that I do for my projects, is I promote this to a variable, and I call this debug type. So sometimes when the AI isn't behaving how I want, I make that public. And when I'm in my behavior tree, we go to Guardian Blast here, and the debug type, let's set the default to none. The default should be none. When I want to check what's going on, if something's being retarded and I'm not sure why, I just set that to one frame or whatever, and I can easily see what's going on to see if things are going wrong. So that's something that I do. So this is set beam point using line trace. What we want to do is we want to check if there's a hit. So branch. If there is a hit, we break the hit. And what we want to check for, well, if the hit is the target actor, so let's just do an equal is here, equal object to the target ref. You know what we might actually do? Let's cut this and put this out here like that. And let's promote this to a new function, collapse this to a function, and just call this set beam endpoint. And this is going to take in a vector, but we're going to grab this vector from here, like that, and plug that into there, and that's just going to be desired endpoint. And I say desired because it's going to be doing the linear interpolation. Sometimes if you want to change your capitalization, it doesn't update if you just change the capital. You need to change the actual name by adding like another letter or something, and then go back and... Oh my goodness, come on, please, please, please. Desired endpoint. Oh, that's... Why the fuck? What if I just give it a few T's? God, that was not helpful at all. Anyway, so that's setting the beam point, and we're going to rename this other function here to find beam endpoint from line trace. Okay, and this is going to output a vector. So let's just add a return node in here. If we have a hit from the line trace, and if the hit is the target, for the hit to be the target, by the way, this is very important because this can confuse the shit out of you if you don't know what's going on. Go into your third person character, or whatever your character is. You need to go to their capsule component, and you need to make sure that the collision preset is set to block all or block all dynamic. I'm not sure what the difference is, to be honest, but it needs to be one of those, because if it's pawn, it doesn't actually get hit by these channel traces. So it'll never actually hit the target if that's not set to block all. So that's very important. If it hits the target, let's create a local variable in here, and let's just call this beam endpoint, and that's going to be of type vector. And what the hell am I doing? We don't need that right now. Let's just put this like this, and if it hits, we're just going to grab our target ref and say get target, get location, sorry, get actor location, and then that goes into there like that, and then this is beam point output. Okay, so if we hit the player, then the output location is going to be the player's location. If we don't hit the player, we're going to check. Well, actually, you can just grab that return node like that. We don't even need this down there, I don't think. If we don't hit the player, we just want to get the impact point and then plug that into there like that, I guess. So that'll be, for example, if it does the line trace to the player but it doesn't hit the player and hits a wall instead, the impact point will be the location of where it hits, and that'll be where we want the beam point to be on the output. Now, the third case is if there's no hit whatsoever, which shouldn't ever actually happen. If it's doing a line trace from you to the target, it'll always hit the target, presumably, because it's got block all in the capsule collision, so that shouldn't happen. So let's just put a print string down here and just say error in find beam endpoint, couldn't hit anything with trace. So that shouldn't happen, but let's just put that in there so if it does happen, we know about it. So now, if we go back into here, we've got an output there. We can just plug that straight into there like that. I don't know why I made those two separate functions, to be honest. I think it is a bit neater actually, because we had two branches in the last function. Joining these back up together and then setting the point could have been a bit of a hassle, but anyway, this will work, hopefully. So let's see if we run around the back of that wall now. So that's on me. You can see the line trace there. That's the debugging thing. And if I run around there, the beam doesn't clip through anymore. Just the line trace clips through. So now, if I go back into our behavior tree and I turn off that debugging, before the beam was clipping through the wall, now it won't do that. So the beam's on us, not on us. And if we watch the wall, it stops at the wall. See that? It's subtle because it's only there for like half a second or something. But that's working like a dream. Okay. Cool, that's done. So beam there, line trace, whatever. Parallel task that changes the eye material while attacking the player. Okay, let's do that. This is really easy. We're going to go into our what do we call it? 2020 BT Guardian. We're going to create a new material in here, and we're just going to call this Guardian. Actually, not even Guardian. No, let's just call this generic emissive color. This is just super simple. I'm no wizard with materials. I'm a fucking noob with materials, to be honest. So let's just, if you hold 3 and left click, you get a color. If you hold M and left click, you get a multiply. Plug the color into the multiply, and then plug the multiply into the emissive color. Let's click on this result node and make this a unlit material, I guess. And then what we want to do is we want to make, oh god, it's going to load and stuff. Let's convert the color to a parameter and call this color. I just call it color with a U because that's how I was taught in school, and apparently I'm incapable of learning outside of school. And then we want an intensity, so add a 1 and left click for a constant, plug that into the multiply, convert that to a parameter which we will call intensity. The intensity by default can be like 10 or something, so it's nice and shiny. And then the color by default can be a nice pretty blue, Guardian blue. Okay, nice. Now what we want to do is if we go to our Guardian BP and we go into our construction script, if we grab our eye, we can say dynamic material instance, plug that in like that. The source material is going to be our generic thingamabob, and we're just going to promote that to a variable which is going to be called dynamic eye mat ref. So now if we have a look at his eye, it's nice and blue like that. We could also make his body like black. Have we got a black skybox black? I mean, I probably shouldn't be using that, to be honest. Have we got like another dark looking material? We've got a creepy face. We got some bricks. We could use some bricks or something. No, that's hideous. I don't really know what I'm doing right now. I'm just trying to make him look a bit cooler. Oh, we could use a metal. What about like steel? That's kind of ugly as well, but you know, whatever. Let's just use steel. This is our Guardian, our pimped out Guardian. So now that we've got his shiny eye, we want to make that so that that's changeable from a behavior tree task. Now, what we could do, well, we only want it to be changed when he's attacking. So let's just add in here a parallel node. And we're going to do the same thing that we did with this yaw to face thing, is we're going to add a new task that'll keep the material set a specific color while this parallel node is running, and then when it's aborted, it'll just change it back to normal. So let's create that now. Blueprint task, go back or dock that up into here, into your the same window as your map, and then we just want to rename that task and call this change generic matte color underscore parallel, like that. Now what we could do in here is we're going to have receive execute AI. We could grab our control pawn and say cast to fucking Guardian BP or whatever, and then get a reference to the eye or get a reference to the dynamic material reference, and then set it. But then this task would be incompatible with all other AI, and we want it to be universal. So what we're going to do is we're going to create a new component, and we're going to make an actor component, and this is going to be called dynamic. What do we call our material? We called it generic emissive color changing component. That's what I'm going to call this. I'm going to add changing component onto the end. Now inside of this, we don't need to do anything actually. No, that's a lie. We might need to do one thing. But what we need to do first is we need to go to our Guardian BP, and we're going to add our generic emissive blah 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 into here. And then what we're going to do is we're going to add a variable for that in here, which is called we're going to call it emissive material ref, and this is going to be dynamic material instance. And now what we need to do is we need to set this. So actually what we could do is we could right click in here, go custom event, and just call this setup, and just plug that like that into there and into there. It'll make sense why I'm doing this in a second. So add that like that. Now in our Guardian BP, after this thing here, we want to drag in our generic emissive component thing or whatever, grab our setup event, and now we just plug that into there like that. So now what we've got is we've got our dynamic eye material reference not just stored in our Guardian BP, which we'd need to cast to access in here, but it's stored in a component that we've called generic emissive color whatever, which can be added to any AI that we want or any blueprint that we want. So now we can grab our control pawn and say get component by class, and it's our component that we're getting is our emissive color changing component. We'll check if it's valid. If it is valid, then what we will do is, let's just promote it to a variable, so just call this material ref. If it's not valid, just have a print string and just say material was invalid for changing generic matte color parallel task. Shitty name, but whatever. So now that we've got that, we will set, do we have a set color parameter or something? No, that's the material ref, sorry. So now we need to say get so yeah, we shouldn't have called that material ref. I think I'm talking a lot of shit. My brain is kind of like switching off, so just kind of ignore what I'm saying and just follow what I'm doing, because I tend to do things accurately, but I don't make sense while I'm speaking. So I'm just going to call this material component ref, which we didn't really need to save, to be honest. This is the bit that we needed to save. So let's call this material ref. This is the one that we actually want. So now that we've got the material reference, which is the dynamic material reference in there, we can say set color parameter or set vector parameter value. And what did we call it in the material? I think we called the parameter color. And now we want to have a variable for the color. So this can be color, like that. We'll make that public. And we can call this active color, actually. And before we set that, let's actually save what the default is. So let's grab our material ref here, and can we say get vector parameter value? We can. So let's get the color that it currently is. You know what, I was going to promote that name to a variable, but this is the only 2 times we're going to be using it, so we might as well just leave that now. And let's promote this to a variable and call this default color. Or you know what would be even cooler? No, actually, let's just leave this like this. This is fine. So the default color is the color that the eye is when this event is called. So we're going to save that, and then we're going to set the color to a new color, which could be red as default. And this is the public one, because this is the one that we're going to be changing. The default color, we're going to leave that unpublic, because that's just going to come from the information that we've got here, which is blue. So now that that's set, we're not going to put a finish execute on the end, because we want it to stay that color. We want this event to continue running, sorry, because it's parallel. And then when we receive our abort down here, we are going to, actually, you know what, let's promote this to a variable, because we are going to use this again. So this is called param name color, whatever. Let's make that public. So that's color down there like that. That's good. That's color like that. And you know, we could even make this public like that, because say if we used a different material, we could. Oh, actually, let's just leave it not public, because I don't want to go into that. We don't need to worry about that for now. So when we receive an execute, we're going to set the vector parameter value back to the original color. So let's copy that there, and instead of active color, we're going to add in default color. And then we're going to compile and save, and then we're going to say finish abort. Like that. So this is receive execute, receive abort. Okie dokie, that should be working. So now if we go into here in our simple parallel, we put in whatever we called that event, something color, so let's just put that in like that. Show property details, we can hide. Now the active color is red, because we want it to be red when he sees us. Now, is that all we need to do? In our Guardian BP, we are setting that up. So this is setting up, set up dynamic eye material and component. Hopefully that made sense why I used a component, because it means that I can just set this up, this simple bit of logic now, I can just copy that into any AI, and then that AI can also use this same task. So now we can use this for any behavior tree, for anything. We could make a whole different bunch of guardians with the same eye switching mechanic. The same eye switching mechanic, that they could all have different colors if we wanted to. We could change the colors just there. And in here we can change the default color here as well. Let's check if that works. Fingers crossed. Check that, red. And he's turning to face us, and then when we run away, he's back to blue. Beautiful. Works like a dream. Okay, that's good. Changes the eye while attacking the player. That's done. How long have we been going for now? Another 20 minutes. Now, rotating search task when cannot see the player. Okay, so when you can't see the player, we're going to have another behavior in here. We're going to get rid of our last wait. Actually, no, we don't need that. That's fine. So we're going to have in a new thing here, which is going to be to search for the player. What we'll do for this... Okay, so it turns out I got way too tired to finish this off yesterday. And I started making a bunch of mistakes, so I randomly cut the video somewhere when I got really stuck and things weren't working, and now it's a new day and I'm going to try and finish off that last task that I was talking about. So we're just going to do the searching for player thing. So we just want the Guardian to be looking around in different directions to see if it can find the player when the can see target is set to false. So we'll go new task, blueprint base. Sorry, just making sure that everything's recording. Dock that. Hit F2 to rename. Oh god, what the fuck? Did I just hit F1 instead? Okay, F2 to rename, and this is going to be called rotate actor to search for player, BTT. That'll do. Open that up. Now, when we receive the execute for the AI, let's cache off the controlled pawn. Now, what we'll do is, well, we're gonna need some sort of, we could probably use a macro actually. So alright, let's try this. Let's chuck in a branch over here. Actually, let me just think for a sec. I guess what we could do is we could just we could find a point to look at around the Guardian. So what we could do is we could say new look at point, and this will be a vector. And when this event's called, what we'll do is we'll set a new look at point, and the way that we're going to set that is we're just going to go vector times by float. The distance can be like 500 or something, or maybe a bit longer. Let's make it like 1,000. It doesn't really matter what the length is, but this needs to be a unit direction vector. So actually, sorry, we're going to need to disconnect that from there. This will make sense in a second what exactly I'm doing. The unit, actually, we don't want a unit direction vector. We want a random vector, random unit vector. Yes, that is what we want. We want a random unit vector. So that'll just give us a random vector of a length 1000 facing in any old direction. What we don't need is the x or the y. We only need the z. So what we could do is, to make sure that this is a length of 1, is we could actually split that there and go make vector, and if you control drag, you can put that in there like that. So now we've only got the z, and now if we type in normalize, this will be of length of 1, and then we can plug that into there, and now it'll be of length of 1000. So it'll be a random vector somewhere on the z, so some random yaw value of 1000, and then if we add that vector to the location of our controlled pawn, so we could say get actor location like that, and then set that as the new look at point. That'll give us a random point to look at. So now what we could do is we could get, we could even promote this. Oh, let's just collapse this here. Let's collapse this to a function and just call this get new look at vector, and that can be a pure function. Actually, let's call that get new look at location, just to be specific, because it's not a direction, it's a location. And then what we want to do is we'll just duplicate that and call this look at, or new look at rotation, and we'll make that of type rotator. And then if we set that here, the way that we're going to get that is we're just going to say find look at rotation. The new look at point is the target, and the start is the controlled point actor location. There is probably a better way to do this, but it wasn't really, I couldn't seem to get it to work in the last video. I'm not going to talk too much about that actually. Like, this kind of seems like a bit of a roundabout way to do it, but I've done this before and this has definitely worked, so let's just roll with this. Sometimes when you're programming, like, the most elegant solution isn't always obvious, or like it might not be working just the way that you want, and sometimes you've just got to make some workarounds, and they might be clumsy and they might look retarded, but if they work, then like, hey, they work. And sometimes you just got to roll with that, and that's cool. So now that we've got the new look at rotation, let's set a timer by function, or timer by event rather. I like to use timer by event because you can visually see it in here without having to dig through your functions up here. So if we say custom event, this can be called update rotation, and then plug that into event like that. The time can be 50 frames per second, so 0.02. Looping, we want to save a reference to that timer as well, so this can be called rotation timer ref. And now what we're doing when we're updating the rotation is we're grabbing our controlled pawn and we're saying set actor rotation, and the new rotation that we're going to be setting is going to be a lerp between A, which is our current rotation, so get actor rotation, and B, which will be our new rotation, which will be the new look at rotation. And then the alpha can just be a variable, which we'll make public over there, and I think we'll want shortest path ticked, otherwise some weird shit might happen where you might look around or back to front and spin around in circles and shit. Now this is being called every 0.5 seconds. Let me just compile and save. So what we want to do off of here, what's this do? This, whether the rotation was successfully set. Okay, that's always going to be successfully set. I think now every time this is called, we want to check, have we reached this location? Now to do that, let's just grab these two here and just say equal rotator within, say, I don't know, like 10 degrees or 10 units. So are the rotations equal? If they are equal, then I guess what we could do is we could go and pick a new point and we could look around again. Or I guess we could just finish this task. So what this could do is, when it's running this branch, so we'll have our task here, which we might as well put in actually. Rotate actor to search for player. Let's set our alpha as a default value of, I don't know, like 0.5 or something. So this will rotate to a new location, and then when that succeeds, this task will succeed and it'll go to the wait, and it'll wait for whatever time, and then once that's finished waiting, it'll go from the root again and then come back down and it'll rotate for a new one. So once this is completed, well, I guess all we'll want to do is we'll just want to clear that timer. So we'll just clear this timer, clear and invalidate timer by handle. So that's if it is equal, and then we can finish execute and finish execute with a success. So now this here can just be called setup. This can be called begin rotation. This can be called update rotation. Check if finished rotating, and then this can be finish execute. So now when we're zoomed out like this, we can basically see what's going on. It makes sense. Okay, so finish execute is marked as a success. That is all set. Let's see if this actually works. So if we... Oh, let's just hit play. Okay, he's now sideways and doing some weird shit. Is he rotating though? Looks like he's turning around to look. I just don't know why he's all crooked and fucked up. I know why. I know exactly why. So when we get a new look at rotation, we don't want this to be just the Z, because just the Z is just the height. So he's found a point that's facing vertically upwards. What we want is we want just the X and just the Y with no Z. I got that back the front. So that's in our new look at location, pure. Okay. Now let's see what's going on. There we go. Every second he's looking at a new point. Cool. Now it is a little bit jerky, so let's just tidy that up. When we set this actor rotation with the lerp, I guess we could just make the alpha like 0.15 or something, maybe make it a little bit smaller. I don't know if that'll completely fix it, but let's see. Oh, that's much better. Yeah, that's cool. Look at that. And you could probably even make it smaller again, 0.05. Let's see how that works. You just want to be careful that you don't go too low, because it starts getting really slow. That's really good. I like that. And his whole body's obviously turning right now, but in a later video I'm going to show you how to make it so just a component turns. I think what I might do is I might make a another tutorial of making a skywatcher, one of these guys that floats around up in the sky. And I'm going to do a bunch of physics for that, and then we'll build the Guardian components into it as well, so it can chase you through the sky. And in that one I'll show you how to set up the rotating component, and I'll also show you how to use build your own pawn sensing as well, because you need your own pawn sensing when you're rotating components like that. I think that's all I wanted to show you guys for this one, so that's going to be the end here. Let's just check that this works with our character. Alright, he's found us. We're hiding. He's gone back to looking around. Now if he looks around and sees us, snap. And you'd obviously want him to play a big scary sound there as well. Cool. Alright, that's it for this tutorial, guys. I'll see you next time. So I said earlier that I've built a Guardian Stalker. I'm just going to show you what that looks like really quick. Now for Asher and Noah, my younger brother and stepbrother, if you're watching this, close YouTube right now, because this is a massive spoiler and you guys need to test this out and be surprised, so no watching. But for everybody else, this is my version of a Guardian Stalker from Breath of the Wild. It's not exactly the same, it's sort of my own twisted variation, but that's it right there with the spider legs and all that. Now if I shoot it, it's not going to turn around and look at me because it might be a bit broken. Oh, it's chasing me now. Oh fuck. Fuck. Oh boy. So you need to hide around these corners and then it can't see you. But it's got the targeting mechanism with the eye. Its head lifts up and down like the Guardian turrets. Oh, and it spawns these things that chase you around. But that's sort of irrelevant to the tutorial. Oh fuck, I'm getting wrecked. Yeah, that's what it looks like. And its projectiles are very fast, by the way. Yeah, like that. And that's its spawning thing just there. But I got the spider mesh off some fantastic guy on some website. I can't remember what it was exactly, but yeah, he walks around with a little 2D blend space, and it's the Guardian head. The head on the Guardian spider lifts up and down, just like the turrets in Hyrule Castle at the end, and it's got the targeting beam and all that stuff that I've just showed you. So that's that.